Hi, this is Dr. Jabali. In this video, I picked some multiple choice questions from past exam papers, which is related to topic 7.3, which is more about translation in more details. This is an HL section. So I'm only going to go through the questions related to 7.3 about translation. And I picked the ones that are the most common seen on the topics related to this section. So first, let's look at the first question. Just remember to read the question 3 times as well as the options because sometimes the options are very tricky and there might be 1 or 2 words that will trick the whole thing. So here we have the first question, and it says the image represents the model of a protein transferrin. Okay, so this is basically a protein. We have it here. And they're asking here, you can see already they're going to be asking something about this section. So which level structure is indicated by the X on the image? So in the image here, if you notice, let's put it in orange. If you notice, it kind of spiral around. So most likely this looks like the alpha helix. And when we think about the alpha helix, that is the secondary structure, right? Also, if you remember, what else is the secondary? We have the beta, right? The beta pleated sheets. So the beta sheets as well as the alpha helix here, these are considered as a secondary. So my guess would have been on that. But if for those who don't remember these stuff, some of them might think, oh, this is going to be tertiary. It's not tertiary because tertiary would have to be, the dotted line should include both. That means it would have to include also the beta here. When you see that, then that would have been a tertiary. Quaternary would have to include like two basically strands here, which you can see the white and the gray. You would have to be 2. And primary would have probably been just this, like a line of amino acids. So the right answer here is B. Moving on to the next question. Where does the tRNA activating enzyme attach the appropriate amino acid to the tRNA molecule? So they want to know, is it an A, is it at D, is it at C, or is it at B, where you put the amino acid? That's what the question is asking. So if you're going to look at this, first you have to recognize what we see here. Usually you see in the book something drawn like this, right? And then he has a circle, and then he has a circle. So students automatically goes and answer B because they see it's in the top because that's where you put the amino acid. Be careful. IB tricked you. What they did is they flipped this. So they flipped this by looking like this now, right? It goes down like this and then like that. So the trick is it's right here. It's on C. So the right answer is C. Be careful. You have to be very slowly analyzing the question because many students will end up putting B because they automatically think of what's drawn in the book. But IB will play with you and they just flipped it around. So the answer is C. So the next question here we have is which types of interactions are found in the part of the protein with secondary but not tertiary structures. So these are talking about the protein levels. If you remember this first, the secondary, the tertiary, and the quaternary. This one, usually you're only going to have the peptide bond, right? The secondary will probably have the peptide bond and it will have a hydrogen bond. So with that, what else could we have for the secondary? For the secondary, it's just an addition. Now, when you get to tertiary, usually you will have something like the disulfide bond because this is coming from the R groups, right? So the R groups have sulfur, but in the secondary, there is no sulfur in the amino acid itself. So it couldn't be, like, what I mean by itself, that means not including the R. So definitely has to be only this. So the question says, again, to what type of interaction are found in the part of protein with secondary but not tertiary. So we know the secondary has hydrogen bonds, and we can only see one here, right? Disulfide bonds, this is definitely going to be a tertiary, and ionic bond is also considered as a tertiary because this is also found all in the R group. So out of this, only the one is, so that means A is the answer. So it's very important that you know the 4 levels of the protein because that's a very common question when it comes to topic 7. So moving on, here says the image is taken from a visualization of an eukaryotic ribosome. So it's a ribosome. The arrow shows the direction of the movement of the mRNA. So here they're basically showing, let me highlight here. You see this is where the mRNA is going. So this right here is the mRNA. Now, which letter represents the tRNA exiting the E site? So when we say E site, that means the exit. So if the mRNA is going in this direction, that means the ribosome is going this direction. So the mRNA as well as the tRNA, they are both going always in the same direction. The mRNA, remember this, the mRNA and tRNA, they both enter the ribosome at the same direction. So of course the tRNA is going to enter here into the A, to the P, and then to the E. So they want to know where's the exit. The exit would be A, so the answer is A. So just as a reminder, remember, mRNA and tRNA, they both enter the ribosome through the same direction as the ribosome goes to the other direction. So moving on to the next question. What are polysomes? So the word poly here means many. And the word somes means, again, ribosomes. This is what they want to say. So there's many ribosomes. So what is basically ribosomes? Think of the mRNA right here. This red line here is the mRNA. And then when you have a bunch of ribosomes at the same time reading the mRNA and producing those amino acids coming out of it, that's known as the polysomes. So looking at the questions, we have a string of amino acids? No. A package of 8 histones with DNA? No. Many ribosome joins to one mRNA? True. Complexes of tRNA with amino acids? No. So the answer is C. So this is also a very common question about 7.3 because that's one part they're talking about the polysomes. But it's a very easy one. As long as you know what polysome is, it's very easy to answer this question. The next one says the diagram of a ribosome. Which letter indicates P site? Just a little thing I want to say, comment here. You will see a lot of questions related to ribosome when it comes to 7.3. So make sure you know everything about ribosome and how it functions. So here they want to know, where do you find the P site? So if you remember, we have the mRNA right here. We have the subunits. Now, which way would it go? Now, obviously, we be stuck here. We don't know if the mRNA is going this way or this way because, again, we don't know if it's 5 to 3 or here's 5 to 3. If you had the number, then it would have been easy, right? So that's why they only said P site, because it's very hard for you to know if it's A or E, simply because they didn't give you a number of the mRNA, so you don't know which the mRNA is going. But P is right in the middle, so obviously it will be right here. So I don't know, I like giving you straight up, I don't know if this would be A or this would be A, simply because right here on the mRNA, right, it did not tell me the numbers at all. So remember that we're reading from a 5 to 3. So obviously if this was a 5 to a 3, then the mRNA would have been moving this way. But if this was a 5 and this is 3, then the mRNA would have moved that way. So we're looking for the numbers next time. They might put the numbers. If they don't, then they definitely not going to ask about the AE. They're going to ask about the P. So the answer is C. And then we have, how do R groups interactions contribute to protein structure? You see how much questions come about these protein structures? That's 7.3 is a lot about that. So again, how do R groups interactions contribute to the protein structures? That means, how do they shape the protein? Determining the sequence of amino acids in the primary structure? No. The sequence, that will be all the beginning of DNA and mRNA. Stabilizing the beta-pleated sheets in the secondary structure? That's not, because again, the R groups are not related to the secondary. The R groups are to the tertiary. And stabilizing further foldings of peptides into tertiary structure. So you can see here, the tertiary is all about the R groups. So it can only be 3, right? So again, it can only be C, which is 3 only. Why would it not be beta pleated? Because this is secondary. And remember, R groups, it's about the tertiary. And that's the kind of questions you find for topic 7.3. It's very short that you find them, but they will be about the ribosome. If it's not about ribosome, it's about the 4 levels of structures of protein. Those are the most common questions when it comes to this. So make sure you know them, as well as also they might sometimes come questions about the tRNA, the connections between the tRNA with the amino acid. But most of the times I see is about the ribosome structure or about the protein levels from 1 to 4. And that's pretty much it. Thank you.